Okay, so let's do some more examples with complex fractions. Remember, a complex fraction is a fraction within a fraction. So here, this is my middle division bar. It has a really fun name. It is called the vinculum. I have a fraction here because I have a numerator and denominator. I have a fraction down here. Remember, this is the numerator of the whole big fraction right here. And these two pieces, numerator and denominator, give me my denominator of the big fraction. So as you can see, I have a fraction divided by a fraction. And to clean that up, I do two things. Number one, I rewrite the fraction in the numerator. And then number two, I multiply that by the reciprocal of the fraction in the denominator. It is equal to the same process. So rewrite the fraction in the numerator. So I have 2x is the numerator of the numerator, and I have 3 times x plus y is my denominator of my numerator. Now I want to caution you. I have a lot of students who they want to distribute this. They think that every time I see a 3 and there's parentheses like this, I want to distribute. Please don't. We want to leave it like this. We are trying to simplify. And we can simplify if we have multiplication. We cannot simplify if we have addition and subtraction. Okay, so please do not distribute this, resist the urge. So that's piece one, right? That is the rewriting the fraction in the numerator. This part right here, taking this fraction and just rewriting it. Okay, now we're going to multiply by the reciprocal of this. So I want this reciprocal. So reciprocal, a over b. If I want the reciprocal, I write that as b over a, right? I just flip the fraction. Okay, so I'm going to multiply this whole thing by, I'm going to write the denominator here as the new numerator of the second piece. And then I'm going to take this numerator right here, 9y, and it's going to be my denominator. So far so good. So let's go through it one more time. If you have a fraction divided by a fraction, you rewrite the numerator. We've done that. Then you multiply by the reciprocal of the fraction that was in the denominator. Okay, then we start cleaning it up. So you can write this as 2 times x, if you want to, times 4 times x plus y, and then 3 times x plus y times 9 times y. If you wanted to, you could reorder this and put the numbers in the front. If that makes you happy. Doesn't really matter. You can leave it like this. A lot of students are uncomfortable if I don't rewrite it, but I'm going to leave it like this for just a moment. I'll show you in a minute how to rewrite it. Now notice this is all multiplication, multiplication, multiplication. Everything here is multiplied, right? All these pieces. So we have a rule that says we can cancel things on top and then on bottom. So a times b over b is equal to a. That's our rule, right? We can cancel the b's because b over b is 1. I'm going to go ahead and erase these. Okay, so I still have multiplication. I just wrote it with parentheses now instead. So now if there's a term in the numerator, everything's multiplied together in the numerator, everything is multiplied together in the denominator. If there's the term in the numerator that is also in the denominator, I can cancel it. So the x plus y's would cancel. I know it may bother some of you that there's an x plus y, but remember that whole term, x plus y, that whole term is multiplied by other things, so it's okay. And I guess that's all that cancels. So let's rewrite what we have. So we have 2 times x times 4. And we have 3 times 9 times y. Now we would never leave it like that. 2 times x times 4. We want all the numbers to be together at the front. So we'd rewrite this as 2 times 4 times x over 3 times 9 times y. Well, what's 2 times 4? Well, that's 8. So I have 8x over 9 times 3 or 3 times 9, 27y, and that's your answer. Let's try another one. This one's a little more interesting. We still have a complex fraction. Hopefully you see the vinculum right here. Okay, so we are going to look at, there's a fraction in the numerator and a fraction in the denominator. So again, if we have a fraction divided by a fraction, we number one rewrite the fraction in the numerator Okay, so we rewrite the numerator And again, it's a whole fraction. You rewrite the numerator, so x plus 3 times x minus 1 over 2x squared times y. And then we're going to multiply by this guy's reciprocal. So I'm just going to flip the numerator and flip the denominator. So I'm multiplying by 2x squared y over x plus 3 times x minus 3. If you want to, instead of writing this multiplication dot, you can rewrite this as one big fraction and put everything in the numerator and everything in the denominator. That's certainly fine. But let's go ahead and just leave it like it is. If you notice, there is a 2 in this denominator and in this numerator. Since it's all multiplied, I can cancel them. I have an x squared in the denominator, an x squared in the numerator. I have a y in this denominator, a y in this numerator. Since it's all multiplied, it's the same as saying y is in the numerator, y is in the denominator. Those cancel. Now let's look at the other pieces. X plus 3 is in the numerator and in the denominator. So your answer is x minus 1 over x minus 3. Stop. Do not cancel those x's. That is your answer. Okay, so some of you may be tempted to do that. Don't do that. You cannot cancel the x's. So I'm going to show you 2 reasons why you can't, 2 examples. Okay, so what if I had something like 365 over, so 365 divided by 37,251. So what if I wanted to say, well, I'm going to cancel those 3's, I'm going to cancel those 5's. So then the answer is 6 over 721. And you would laugh at me and you would tell me, you can't do that. That's garbage, right? So the reason you can't do that, that's like 300 plus 60 plus 5. This is 30,000 plus 7,000 plus 200 plus 50 plus 1. So you knew when I did it here that it was wrong, but the reason it's wrong is because of all these addition signs. You can't do this when you're adding or subtracting. So here's another reason. So let's go back and look at the answer, x minus 1 over x minus 3, and I'm going to pull a number out of the air. So let's just suppose that x is 13, because x is a variable. That means it's able to vary. I can pick lots of different things for it. So if x is 13, I get 13 minus 1 over 13 minus 3. Well, what is 13 minus 1? It's 12. 13 minus 3 is 10. Okay, and you can reduce this, and this is divide both by 2. So you get 6 over 5. Or you could even look right here, and this is 1.2. I'm just trying to demonstrate a point. So if you wrote x minus 1 over x minus 3, and then you canceled incorrectly, don't do it, cancel those x's, you would say your answer is negative 1/3. So these are definitely not the same thing. First off, one's positive, one's negative. We know this is 1.2, or a fraction representation of 6/5. Not the same thing. So you cannot cancel those x's. And it's because there's subtraction in here. If they were multiplied, then you could. Okay?